Hello, there are actually two formulas to test for independent events. So the first formula is the conditional formula. It's the probability of A given B equals the probability of A. And we talked about how the condition B shouldn't alter the probability of A if it's independent. Now, we do know that the probability of A given B is the probability of A and B divided by the condition, the probability of B. So if these are independent, then using the conditional formula, the probability of A and B divided by the probability should equal the probability of A. Then what they did was they multiplied both sides by probability of B, and that's how they got this new formula that we can see on the right-hand side. The probability of A and B equals the probability of A times the probability of B. But it's really just the first conditional formula that is manipulated to look like something else. It is important to know both because depending on the information that they give you for the Regents questions that you'll see here, you might have to use one formula or the other. So for example, in the first one, the probability that Gary and Jane have a child with blue eyes is 0.25. I'm going to write it as I go. Probability of blue eyes is 0.25. The probability that they have a child with blonde hair is 0.5. The probability that they have a child with both blue eyes and blonde hair is 0.125. The events blue eyes and blonde hair are what? Now, we have talked about that if you see dependent or independent, it is one or the other. Now, mutually exclusive means they cannot happen at the same time, but it is possible that a child could have blue eyes and blonde hair at the same time. So they are not mutually exclusive, meaning it is either choice 1 or 2. Now, you have two independence formulas. One is conditional, one is the multiplication rule. Which one are you going to go with? We don't have conditional probability, so it would make sense to go with the multiplication formula. That means I'm going to do the probability of blue and blonde hair equals the probability of blue times the probability of blonde. Now, the same thing holds true for this formula like the other one. If they are equal, they are independent. So we have blue and blonde is 0.125. Blue is 0.25, blonde is 0.5. You're going to throw it in your calculator, and you're going to see when you multiply them together, what do you get? And we get that they are equivalent, meaning it is independent. That means that whether you have blue eyes or not, that doesn't affect the probability of you having blonde hair. For the second one, on a given school day, the probability that Nick oversleeps is 48%. The probability that he has a pop quiz is 25%. Assuming the two events are independent, what's the probability that Nick oversleeps? Oops. And has a pop quiz. So let's see what we have. We have and. We do not have conditional. And because we don't have conditional, don't use the conditional independence formula. You're going to use the multiplication formula, meaning the probability of oversleeping and having a pop quiz is equal to the probability of sleeping times the probability of having a pop quiz. It's one times the other. So we got, let's see, sleeping is 0.48 times quiz is 0.25. That is going to give you our desired amount. So 0.48 times 0.25 is 0.12. There is a 12% chance. You can only use these formulas, though, if they tell you that they are independent. So, for example 3, at a lakeside resort, the probability that a guest has a room, that the room has a view of a lake is 0.24. The probability that a guest has a room with a queen-size bed is 0.74. Let A be the event that the guest room has a lake. Probably should have read this beforehand. And B is the event that you have a queen-size bed. There we go. They are found to be independent of each other. They want you to figure out the probability that the guest room has a view of the lake and has a queen-size bed. So, because they tell you you are independent, you could use one of these two formulas. They're asking you to find the probability of A and B, meaning use the multiplication formula. So we are going to write the probability of A and B because they want and probability equals the probability of A times the probability of B. Probability of A is 0.24. Probability of B is 0.74. And that means the probability of A and B is going to be 0.1776. Now, I am not rounding because they did not tell us to round. Now, part B says determine the exact probability that a randomly selected guest room has a view of the lake or a queen-size bed. There is only one or formula, and anytime you see or, the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So probability can be tricky because there's so many different formulas, but you have to keep your eye on the lookout for if it ever says or, use this formula. You know A is 0.24, B is 0.74, and you have A and B is 0.1776. End up with the probability of A or B equals 0.8024. They did not ask you to round. Don't do it. We got one more question left. These are all Regents questions, by the way. Sometimes they could get pretty difficult. Given events A and B, such that the probability of A is 0.6, probability of B is 0.5, and the probability of A or B is equal to 0.8, they want to figure out whether you are independent or dependent. I wrote the two formulas on the side. Notice how none of them have what they actually gave us. They gave us or, and anytime you are given or, you have to use the or formula. Probability of A or B equals probability of A plus probability of B minus probability of A and B. Let's just plug in what we know, see where it takes us. We have the probability of A is 0.6, probability of B is 0.5. We have or probability is 0.8. Do not have probability of A and B. Maybe they want us to actually solve for it. Who knows? I'm just going to do whatever I can. You have 0.8 equals 1.1 minus P of A and B. I'm going to add probability of A and B to the other side. And I get probability of A and B plus 0.8 equals 1.1. I'm going to subtract 0.8. Probability of A and B equals, what is that, 0.3? So the point is, now you know that the probability of A and B is 0.3. How does that actually help you? You have to go back to what the question actually wants. And what the question wants is whether you are independent or dependent. You have to use one of these two formulas. Well, now you have and probability. So you are going to use the one with what you got. The probability of A and B equals probability of A times the probability of B. We have that the probability of A and B is 0.3, comes from right there. You know that the probability of A is 0.6, the probability of B is 0.5. So 0.6 times 0.5 is 0.3. You get that 0.3 equals 0.3, meaning they are independent. Thanks for watching.